Title 1.3 Mastering Antenna Terminologies for Electronics and Communication Engineering. Welcome to the ElectroProfessor. In this video, we delve into the world of antenna terminologies, covering a wide range of essential concepts. Join us as we explore the fundamental principles of antennas and their performance characteristics. We start by understanding the difference between aerial and antenna, and delve into topics such as antenna impedance, radiation resistance, radiation pattern, beam area, beam efficiency, isotropic radiator gain, directivity, radiation intensity, half power bandwidth, polarization, antenna losses, antenna efficiency, effective aperture, effective length of antenna, effects of antenna height, antenna temperature, front-to-back ratio, antenna field zones, and power radiated by an elementary dipole using Poynting vector. Aerial and antenna. Aerial is a term often used interchangeably with antenna and refers to a device or structure that is designed to transmit or receive electromagnetic waves. An antenna is a specialized device that converts electrical signals into electromagnetic waves for transmission or vice versa for reception. Antenna impedance. Antenna impedance refers to the complex resistance offered by an antenna to the flow of electrical current. It is typically represented as a complex number and is an important parameter in antenna design and matching to the transmission line or receiver. Radiation resistance. Radiation resistance is the portion of the total electrical resistance of an antenna that is responsible for the conversion of electrical power into electromagnetic radiation. It represents the power radiated as electromagnetic waves by the antenna. Radiation pattern. The radiation pattern of an antenna is the graphical representation of the directional properties of its radiation in 3 dimensions. It shows how the antenna radiates electromagnetic waves in different directions and is typically represented as a plot of the field strength or power density in different directions from the antenna. Beam area and beam efficiency. Beam area refers to the total solid angle over which the radiation pattern of an antenna is concentrated. Beam efficiency is the ratio of the power radiated within the beam area to the total power radiated by the antenna, expressed as a percentage. It indicates how effectively the antenna concentrates its radiation in a particular direction. Isotropic radiator gain. Isotropic radiator gain is a theoretical concept that represents the gain of an ideal antenna that radiates equally in all directions with a perfect spherical radiation pattern. It is used as a reference for comparing the performance of real antennas. Directivity and gain. Directivity of an antenna is the measure of its ability to focus its radiation in a particular direction. Gain is the ratio of the intensity of radiation in a particular direction from the antenna to the intensity of radiation from an isotropic radiator in the same direction, expressed in decibels, dB. It represents the increase in the power of the radiation in a particular direction compared to an isotropic radiator. Radiation intensity. Radiation intensity is the power radiated per unit solid angle in a particular direction from an antenna. It is typically measured in watts per steradian, W/SR, and provides information about the concentration of the antenna's radiation in different directions. Half power bandwidth, BW. Half power bandwidth is the range of frequencies over which the radiation intensity of an antenna is at least half of its maximum value. It is a measure of the bandwidth or frequency range over which the antenna can efficiently transmit or receive signals. Polarization. Polarization of an antenna refers to the orientation of the electric field vector of the electromagnetic wave radiated by the antenna. It can be vertical, horizontal, circular, or elliptical, and is an important parameter for matching the polarization of the antenna with that of the transmission or receiving system. Antenna losses. Antenna losses are the losses that occur in an antenna due to various factors such as resistive losses in the antenna structure, dielectric losses in the surrounding medium, and mismatched losses between the antenna and the transmission line or receiver. It represents the reduction in the efficiency of the antenna. Antenna efficiency. Antenna efficiency is the ratio of the radiated power of an antenna to the total input power supplied to the antenna, expressed as a percentage. It represents the effectiveness of the antenna in converting the input power into radiated power. Effective aperture. Effective aperture of an antenna is a measure of its ability to capture or receive electromagnetic waves from a particular direction. It is related to the physical size and shape of the antenna and is used to estimate. Whether you're a student, a professional, or simply interested in antennas, this video is packed with valuable insights to enhance your understanding of these critical concepts. Join us on this educational journey as we unravel the mysteries of antennas in electronics and communication engineering. Don't forget to subscribe to our channel, The ElectroProfessor, for more informative content on antennas, wave propagation, and other topics related to electronics and communication engineering. Hit the notification bell so you never miss a new video. Feel free to leave your comments and questions below, and we'll be happy to address them in future videos. Thank you for watching.